It's my great pleasure to talk about a topic that I'm enthusiastic about. I'm not a developer of the Shinylive and I'm not a WebAssembly developer, but I recently discovered these tools and I think they are amazing and there are so many fun things that you can do with them. So this is why I decided to submit it to the conference, to talk about it and hopefully give other people some ideas. But let's set the stage. Let's start with a few pain points that typically arise in web development or in app development with Python. So the traditional web apps, they usually rely on some sort of server backend. So Flask, Django, Fast API are probably frameworks that you are familiar with. These are also frameworks that I have played around with. I'm not an expert on any of those, so please don't ask any questions about them. And on the front-end layer, you could either create your own JavaScript front-end if you are a web developer, or you can use Python frameworks like Streamlit or Dash. The problem, at least for me, I'm an experienced R user, and I've used the Shiny framework, and when I had to create Python web apps, I was surprised. I have to do all sorts of state management and take care of caching, and things can get complicated quite quickly, complicated and annoying. And another thing to keep in mind, usually these apps, in particular if they have multiple components, there's quite some deployment complexity involved. Now, the tools that I want to show you today, they tackle these issues. Let's start with WebAssembly. Maybe some of you have heard about it before. It gives an obscure definition of WebAssembly on the website. It says it's a binary instruction format for a stack-based virtual machine. So I don't have a computer science background, so I have no idea what this means. But in practice, how I think about it, it means that WebAssembly can run compiled code in the browser. So this is pretty cool. So your Chrome, your Safari, your Edge can run C, C++, Rust, or Python code. Also R, people are working also on this. And it's a near native performance. So we're not losing anything there. And the cool thing, if you think about web development, this unlocks a new area where we can actually build a web app that runs completely in the browser, so you don't need a hosted backend server. So this sounds like too good to be true, and yes, it is. So there are some caveats, and I will talk about them a bit later. But if we can create apps without a dedicated backend server, we can basically deploy apps as static websites. So I will show you an example where we do exactly this. I will give you an app that is statically deployed using GitHub Pages that you can try out. So if you have used GitHub Pages and Netlify, this means you can just deploy a Python web app that uses data, has some interface, people can play around with it. You have basically no maintenance costs, you don't have to pay for a server or anything. So that's pretty cool, I think. And I will talk about use cases, I'll give you some ideas later. In addition to WebAssembly, there are two more concepts that I want to introduce, so Shiny and Shinylive. So for those of you who have experience in R, you're probably familiar with the Shiny framework. So that's the go-to framework for building dashboards or apps in R. And recently, the POSIT company, they translated the Shiny framework to Python. But the cool thing is, it's in pure Python. So this is very useful when we talk about deploying things using WebAssembly. The cool thing about Shiny, and I will give you a code example that illustrates this, but just why I think Shiny is cool. First, you don't have to take care about state management. So if you have written callback functions before, so you don't have to do this. Frankly, that's something I, in Python, really struggle to do. So This is why I usually went back to R to do a simple dashboard. You get an automatic reactive execution engine. So as you will see in the example app, if we change the inputs, Shiny takes care of which elements should be re-rendered. So you've probably used Streamlit before, right? And if you change an input in Streamlit, the whole site renders again because Streamlit is creating an HTML file and then it's doing it all over again whenever you change an input. And this feels like, I don't know, 1990s internet. But with Shiny, you get an automatic execution engine. So it takes care of these issues for you. You also get full support for CSS and JavaScript customization. So as I'm an independent consultant and I do dashboard building for a couple of clients, and you can spend a lot of time customizing dashboards using CSS and JavaScript, but the good thing is that at least the front-end and back-end components Shiny takes care of, and you can do the customization layer on top. So this was Shiny, right? Shiny is about building web apps. We'll give you an example in a minute. Shinylive is just a framework that allows you to run Shiny apps entirely in the browser. So what it's doing, it's taking your Shiny app and providing instructions how you can run this in a WebAssembly, using WebAssembly. And maybe you've heard about it, PyData, that's the leading framework for WebAssembly in Python. Essentially, it's a port of CPython to WebAssembly. So probably one could give a whole talk about PyData alone. I think this is it's an amazing and exciting project. But the cool thing is with Shinylive, you don't have to take care of this, of the nitty-gritty details here. You can, you're assured that Shinylive takes care of all the PyData organization for you. But just to illustrate the concept, right? A traditional Shiny, if I create a Shiny app or any app in Python, usually you have a Python process that runs on a server, and you have a couple of clients that access the server, and the server executes the code. The server takes care of maybe load balancing, caching, all these things. And for data apps, of course, it also runs the code, right? So if you're doing some aggregations in response to changes in the UI, then the server is taking care of this. Now, with Shinylive, how we can think about it is that instead of the server doing all these computations, you have little Python processes running on the client side that do all the work. We will come back to a similar image like this. It's not like we can get rid of the server for all the things that we want to do with web apps, of course. So things that might come to your mind are, oh, how Christoph, but how do you handle authentication? How do you handle secrets and stuff like that? We'll get to this. Let's take a look at a code example. So for those of you who are familiar with the R Shiny framework, this will be very familiar. And for those of you who are new to this, I will walk through it. So I try to make a very, very simple app. So first, we talk about the code. We will revisit this later, this example, because we will extend it. But we will also look at the live app. So I use matplotlib, right, for visualization. I use NumPy because I want to plot some numbers, vector of numbers. And I use the Shiny library. In particular, there are only 3 functions that I need. So the app, render, and UI. And this is how you typically approach a Shiny app. And again, coming from R, this was of course very natural to me, but you think about how do I define the UI? What are the components? What is the layout that I want to use? So a simple layout could be page sidebar. Right? So we use the UI, define the page sidebar, and then you would, for instance, introduce a sidebar with a slider. So as you can see, The Shiny framework provides some UI components, such as page layouts and, for instance, sliders, but you also get text boxes, check boxes, radio buttons, stuff like that. They even have a chat interface if you want to build an LLM into your Shiny app. And in the slider, I would just define what the slider is called and the name of the object, and minimum, maximum, and the starting value. What you would also do in the UI is define output components. So what I want to do here is just plot a histogram using this input slider that picks the number of bins as a UI input. So you could define, right, output plot is a histogram, but this could also be output table, output text, output HTML, I don't know, stuff like that. So different outputs that you tell Shiny what the type is, and it takes care of the rendering. And I will also include this title, Hello PyData Berlin. So once you have taken care of the UI, what you do is you define a server logic. You could do this in the same script as I do here, right? It's the same app.py file, but you of course can split it up across multiple scripts, as you would usually do. And if it's a bigger project, maybe you would even isolate different server components, different UI components, right? And then assemble them in one main script. But what happens here, you define this server function, you use the decorators that are shipped with Shiny. Essentially, you can think about decorators as they wrap the functions that come afterwards in the output or render plot function. At least intuitively, that's what's happening. And what you basically do here is, right, so you have the output. On top, we have defined our histogram output. So in the server, we have to define what this histogram looks like, how it is created. And render plot also indicates that you're actually rendering something. So matplotlib or Seaborn or something like that is used. And I would define the histogram as a function here. So I'm using NumPy to define a random seed, and then just in line 19, you see I'm creating a vector of random numbers using NumPy, and then just plot histogram. And also very important here, right, is the bins. We have input n. So this is exactly the n that we defined above in the slider. And if you want to start this app, you would just run this. So app, the app function, you use the app UI and the server as an input. So this is a Shiny app, right? So what you define the Python code, what should happen. What does Shinylive do? Shinylive exports this app to something that can be executed using WebAssembly. So if you run Shinylive export app to a docs folder in the terminal, what you will get are a couple of files. So in the docs folder, you will get an app.json. So that's basically the logic of the app. The whole app serialized to a JSON. So we will look at this again later. An index.html, that's just a simple web page that displays the application, so there's not much happening here. I'm going to skip the edit folder because you can also get an editor view of an application that's usually not that important. But crucially, there's a Shinylive service worker, and there are also PyData files. So what the Shinylive service worker does, it takes care of, okay, what do I need from PyData and what do I execute in the browser? And PyData basically delivers all the libraries that you want to use. Okay, a few more things before we look at the live app. So you can already grab your phone. So the script that I've shown you before, the app py, if you run Shinylive, it is encoded in this app.json. So this is a bit, so it's abbreviated here. I cut this off because, I mean, it's just, right, it puts all the Python script into one line. It's very long, but as you can see, what happens at the top is it imports matplotlib as PLT, import NumPy, blah, blah, blah. So this is exactly just the Python code, right? So the first thing you might realize here, oh my God, everything I put in my Python script is in this app JSON, right? And if you deploy this as a public website, then this will be public. Keep that in mind. But deploying Shiny apps, Shinylive apps as static websites is super, super simple. So if you have deployed something with GitHub Pages before, it's just the same. You just point GitHub Pages to a docs folder. I'm not going to go into details here. I'm just going to refer to a guide, a walkthrough by Rami Crispin, who has done some work on this. But again, it's very simple. GitHub Pages has become very, very easy to navigate these days. Now, I invite you to test the deployed Shiny app for those of you. So what you will, if you it should work on your phone. If it doesn't work on your phone, please approach me afterwards, because I really want to find out why it's not working. So if you start the app, so what happens now is that your browser has to download the app files. It's taking some time probably, because we're all connected to the same Wi-Fi. And what your browser does, it starts up a Python session, runs the app, and should host it in your... so you should see a similar simulation icon like this. Right? It's a super simple Shiny app. So there is a slider here. If you change it, the histogram changes because you vary the number of bins. So that's not too bad, I think. It's very easy to create something like that. But I want to show you like what's happening in the background. So I've used the developer console in my browser a lot, so I can recommend you to dabble with this. So if let's reload the app, what's happening in the background? So you can see there are a couple of packages being downloaded. So what's happening here, for instance, it's a bit small, but you might see that matplotlib is here, Shiny is here, PyData is here, NumPy is here, and you see that there are also some bundle sizes here, right? So 6.5 megabytes for matplotlib, PyData, NumPy is here, so there's a couple of megabytes. So what the browser is doing, it's downloading everything, just quickly installing it, and it's pretty fast actually, right? If you think about it, it loads libraries and installs them. What I have done here is I have disabled caching because typically browsers, they also cache these things. So if I enable caching, which is, again, it's the default setting, then your browser already has those libraries and it will just load them, so you don't have to download it. That's also pretty neat, I think. So I hope, was there anybody where it did not work on the phone at all? Okay, great. Please, let's chat afterwards.
It also didn't work on a different browser, on Edge.
On Edge, great. Let's check it out afterwards. That's an amazing learning experience for me. So, simple app. We defined the data in the app. I just want to give you a few more ideas. You could ship data with the app. Of course, you could ship CSV, but maybe you have heard that CSVs were very bad and they're outdated, so everybody's using Parquet files now. Wait, let me go back to the full screen mode. And just a one-liner, Parquet, that's efficient, compressed columnar data format, so you can store tabular data very efficiently. And you can, of course, also just read it in your browser using PyArrow or the Polars library that we've seen today in an earlier talk. And I think it's just very easy to use if you have very small data sets, just a couple of megabytes that can be downloaded with your app, or offline first apps. But of course, the big disadvantage, the app JSON that we've seen before is public. So any data that you will include here is first, it's static because it's just a Parquet file that you ship with your Shiny app. And second, it's potentially public if you host your site on a public website. Of course, you can firewall it and everything. So, but these are other topics. So if we want to include Parquet data in our Shiny app, what changes? I'm using Polars here. I'm importing it to read a Parquet file that I have previously defined. So it just lives in a app Parquet folder. It's just called data.parquet. The UI is exactly the same. The server is almost the same. Since we are reading the data in, instead of simulating it, what's happening now is we use the data frame column values, and we're converting it to NumPy and then use this data to plot the histogram. But everything else is the same. And what Shinylive does, right, we do the same. You Shinylive export the stuff to a docs folder. Again, at the top, you will have the app.py. It's very simple, similar. I mean, now we have import polars that's happening at the top, right? But then you get also another object. So the app.json now knows, okay, you're also shipping this data Parquet, and it has some content. And this is just, this is how Parquet is encoded here in the JSON, and it's a binary file format. So of course, polars in your browser will know how to read this. And if you would ship a CSV file with your Shinylive app, then you would see the values of the CSV here, right? Just separated by commas. I want to give you a few more ideas. So if you want to create a showcase, right? Showcase your work, something that can be public, that can be static, this is a very quick way to do this, right? You have a small project, you want to just show people what you have achieved. You can create an app, let people play around with what you have done. But for many use cases, in particular business use cases, you need other authentication, you need backends and stuff like that. So one thing I have played around with it, of course, is using a fast API backend, so you can offload some compute or storage tasks to a dedicated server. So then you would need so I use a fast API container that takes care of some aggregations and then just passes the data that the Shinylive app needs through an API call. You can also handle authentication in fast API easily, remote database access. So for instance, if you have a database, fast API can be the layer in front of the database. Usually it should be like that. Don't give direct access to a database, right? Or it could do some heavy lifting. Yeah, and then you just build the API endpoints with fast API. I know, so still you're thinking, okay, Christoph, now I have Shinylive, but you're using a backend again, you're introducing complexity, but at least the hosting of the app is taken care of because this runs in the browser. So you don't have to do all the computation and all the rendering in your backend. You can focus on a backend that is specialized on aggregating data, creating predictions for a machine learning model, I don't know, stuff like that. And the disadvantage is the authentication may be complex. Just to give you an idea of something that I have walked through to figure out what Shinylive can do and how far we can push things. I'm not going to give you the full example, obviously, because there's so many components involved. But for instance, you can have a user that logs in with an email, uses a Firebase or Supabase-based authentication UI. This provides a JWT token that you pass on to the Shinylive app. The Shinylive app then sends requests including these tokens to a proxy that passes it to a fast API container that validates the authentication and then pulls the data from mother duck. For instance, this is something I work with static data. And then you can stream Parquet files back to the user and to the Shinylive app. Of course, you can do these things, there's a lot of work, but you can separate clearly what each of these components are doing. Just to give you some idea, if you want to use Shinylive and authentication and remote databases, things can get nasty, but it's possible. So a few design patterns before I close. When the data sets are small, the apps are very simple. You can do everything on the client side, and if the data can be public. As I've just described, hybrid mode can make sense if you have need a backend for authentication or maybe even write access to a database. You could handle this there. Because every secret that you will include in the Shinylive app will also be on the client. So you have to be very careful here. Yeah, also keep it in mind if you create more and more complicated server logic, remember everything should be stateless here and make it modular. And I think what makes it great and Shiny is that the reactivity that ships, that comes with Shiny simplifies the UI logics tremendously. A few limitations to be aware of, as you've seen in the developer console, bundle size, right? We have downloaded a couple of packages. PyData is 3 megabytes, NumPy is 2.5, Pandas is 4.1 megabytes. These things change actually. So I think the last time I downloaded Polars, it was like 25 megabytes, and I was like, holy crap, I cannot use Polars in the Shinylive app. But developers are aware of PyData and the growing popularity of PyData, and they're also optimizing bundle sizes. But this also means if you create a package that you want to use in a Shinylive application, you should also think about the dependencies, right? What do you include? Because everything has to be downloaded in the browser. The initial loading time can be a deterrence. So as you've seen on your phone, right, you had to wait for a couple of seconds until everything was loaded, installed, and spun up. Of course, in production context, where you create a product, a user-facing product where people pay for it, they're probably annoyed by this loading time. So maybe that's not the perfect use case, but I guess if you're doing an internal dashboarding solution, right, where people use this once a day, then this could be very attractive because you can have a very simple server that doesn't do much and the browsers do all the other stuff. Limited packages. So I've emphasized that Shiny is in pure Python. All packages that are in pure Python can be easily installed using PyData. If you need some C extension, it needs to be WebAssembly compiled. I recently discovered this because I ran into this issue because I use a fixed effects estimation library that uses Numba, and Numba is based on LNV Lite, and LNV Lite has not been compiled to WebAssembly yet, and it's not even possible whether it's not even clear whether this is possible, so I cannot use this Python library. So these are the things that you might run into, but for the most, like the basic applications, this works. And of course, browser memory and performance constraints. So WebAssembly, it runs in the browser and it has certain restrictions. So there is there's some restriction with terms of memory. I think it's 4 gigabytes or something like that. And you only get one core. So if you want to have an app that does parallelization, no, it's not going to fly. But that's not usually the use case, right? You want to display something, it's very simple. So when to use it, dashboards, I've iterated this, small data apps, potentially behind firewalls, education context, demos, data explanation stuff, that's great. You can easily deploy it with GitHub pages. It's not ideal for real-time streaming or huge data sets. I guess you can find workarounds because you have to introduce a couple of layers that do the work. And yeah, complex authentication, role-based access controls, that's typically the nightmare for web development. So it's also Shinylive doesn't solve this for you. All right, so to wrap it up, I'm a big fan of this. Because I think, so first, WebAssembly is pretty cool, it's new, and Shinylive also makes it easier, at least for me, to create dashboards in Python. I think they open new doors for Python in the browser, so I'm really curious to see where this whole field goes in the next couple of years. Yeah, Shiny and Shinylive allow you to create fully reactive apps without JavaScript and explicit callback functions. If you want to include or ship data with your Shinylive app, I can recommend using Parquet. Fast API can help to create more complex or some hybrid frameworks. And last but not least, if you want to stay in touch or reach out, feel free to follow me on LinkedIn on the left, or if you want to check out the GitHub repo that contains the slides and the app and everything, that's the QR code on the right. Thank you very much for your attention, and I'm looking forward to the questions.
Thank you very much. So we have time only for one question, and I will take the most voted one in the app. Can the app process big amount of data points, like 10 million? Will you not break the browser?
Sorry, which models?
Yeah, if the app can process a big amount of data.
Big amounts of data. Well,
That's
as I said before,
million.
you are restricted to the memory of a couple of gigabytes in the browser. So, right, it's a good use case for simple things, simple data. You want to illustrate something, but the processing should be in a powerful server. Yeah.
Okay, thank you. Maybe another one. Yeah, do Shiny and Shinylive also work with Plotly interactive figures?
Yeah.
Yeah.
Yeah. So in R it works, and in Python it should also work. I have not tested it, but it should work. I see no like all the Jupyter widgets, everything works as well. So it's very flexible. Yeah.
Thank you. We have time for one question here in the audience. So, yeah, just a quickly one, okay, because we're over time already.
Thank you for this interesting talk. What about authentication to data sources? If I want to connect to a database or something, is it possible, or is it? So or do I need a server and then?
So authentication on the public web is a nightmare.
No,
if you do it in a firewalled environment, you can think about also providing it.
I don't need my, even in the corporate context, I don't need my peers to know the credentials.
Yeah. But you could fire up the app with a simple provide a key, right? A login mask, and then the app passes the login mask to the wherever you need to authenticate. And then the app just in your browser carries these secrets, but you don't deploy it to anybody else. So this would be a simple solution for the user provides it. Yeah. Then you can think about storing it in the browser as cookies. I don't know, something like that, right? But these are the restrictions, unfortunately, with this WebAssembly stuff.
Very nice. Thank you very much, Christoph. And
thanks, everybody.
Once again.